Welcome students to the last screencast of our electrochemical engineering course. This time we will discuss electricity markets. And you might wonder, why do I need to learn about electricity markets? The reason is that electricity is one of your main raw materials in an electrochemical process. Or it's actually your main product, for example, in a fuel cell. So then it's good to understand what determines the electricity price. And for that, you need to have a basic understanding of how the market works. And that's what we will discuss in this module. Before going into the specifics of electricity markets, let's first discuss the fact that the way we generate electricity in our world is changing. We are moving from a system based on fossil fuels and a bit of hydropower to a system based on renewable electricity sources. And an important difference between these two systems is in the fossil system, the electricity generation could easily adjust itself to the demand. Especially gas-fired power plants are very flexible. And that led to a situation where the electricity prices were always relatively constant. Now we are moving towards a situation with a lot of wind and sun, and windmills and solar panels don't adjust to demand. They just deliver when the wind is blowing and the sun is shining. And this will lead to a mismatch between supply and demand of electricity. And this will in turn result in fluctuating electricity prices, and it will also result in the need for short and long-term electricity storage. We should also not forget that our energy transition is not just about turning fossil electricity into green electricity. We also have to think of our other energy demands, namely heat, transport, chemistry and metals. These sectors also will need to become sustainable, and basically the only possible way is to make use of electricity to greenify these sectors. And for heat, this can be done via power to heat, for transport via power to fuel, and for chemistry and metals via power to products. As a result, we will need much more electricity to cover these sectors. So the electricity market, in the Netherlands now about 100 terawatt hours per year, will have to grow significantly. And this will also have a significant influence on how the electricity markets will behave in the future. Now let's discuss how electricity markets function. It's a market, so there are parties that want to buy electricity and there are parties that want to sell electricity. And it's the function of the market to bring these parties together. What is important is that you can do this at different times. You can, for example, decide today that 3 years from now you want to buy electricity. Then you can go to an electricity provider and you can make a long-term contract 3 years in advance. So you can say, well, I need 1 terawatt hour of electricity in 2024, and then the electricity provider say, no problem. Another possibility is that you say, I need electricity now, really now. And then you have to go to a different market, namely the balancing market, which is managed by the grid operators. Now there are more of these markets. You have the intraday market. You also have the day ahead market. This is the most important electricity market. So most of the electricity is bought and sold on the day ahead market, and this is really where the most important price of electricity is being set. So a day ahead means that is just basically the electricity of tomorrow that is being bought and sold on that market. So how does this day ahead market function? It's an auction process in which supply and demand are brought together, and it makes use of a so-called merit order. Now that takes some explaining, so that's what I will do. Let's start with the demand side. So you have to the market, all the parties go that want to buy electricity. Of course, not you and me as consumers, but the big electricity companies that that you buy electricity from at home, but also industrial parties, for example, aluminum plants. And these parties indicate the amount of electricity they ideally would like to buy tomorrow, and they also indicate the maximum price they are willing to pay for that. Now, um, first you have the consumers, basically the parties, the electricity companies that buy electricity for consumers like us. These companies are willing to pay very high prices because the last thing they want is that they have to say to their customers, well, tomorrow there's no electricity because we didn't manage to buy it on the market. But there are also parties like the aluminum plant that can say, yeah, we were willing to buy electricity, but not if it's more expensive than, say, for example, 40 euro per megawatt hour, because if it's more expensive than that, it makes more sense for us to shut down the plant. So this leads to a so-called demand curve. So what do you see here? On the x-axis you have the quantity, and on the on the left axis you have the price. And basically here are the electricity companies for the consumers. They want a certain quantity and they're willing to pay a very high price for it. On the other side, you have, for example, here the aluminum plant. Um, about 40 euro per megawatt hour, that's what they're willing to pay. So it's a much lower price and still a significant quantity. And you have other parties sitting there somewhere in between. So for them, some companies might say, well, we do like our electricity, but if it's more than 100 euro per megawatt hour, yeah, then we will shut down our process. So this is the demand curve. Then you also have the supply curve, and for that we have to look a bit here at the right, because the supply consists of windmills, possibly nuclear power, gas-fired power plants, coal-fired power plants, and maybe other electricity sources. And they basically do the same thing. They say we are willing to produce electricity tomorrow, but only if we get a certain minimum price. Now, the windmills and the solar panels, basically they can put a very low price, because if the wind is blowing and the sun is shining, it doesn't cost them anything to produce that electricity. Of course, they first look at the weather forecast, whether the wind is going to blow and the sun is shining. But if they know that, of course, they have very good weather prediction. So they can say, yeah, we are willing to offer electricity at a very low price. Also, a nuclear plant typically can go low, but for gas and coal-fired power plant, it's quite different, because for them it depends on the price of natural gas and the efficiency of their plants. So you have very new plants that are very efficient, but you also have older plants that are less efficient. So for the new plants, they can give a relatively low minimum price, but these older plants have to give a higher price, because their plant is less efficient, so they need more natural gas, to generate the same amount of electricity. So that makes their variable cost higher, so it's also their minimum price is higher. So now, and this also, now we go back to the left. Basically, this then results in the supply curve. And so we have a demand curve and a supply curve. And now these two are being brought together. And they basically look then, where do the lines cross? That will then be the market volume and the so-called price. So here, for example, the conclusion is, in the end, the price will be 50 euro per megawatt hour. What does that mean? That the consumers that were willing to basically pay anything, they will get their electricity. The aluminum plant will not get the electricity. because they only wanted to pay 40 euro per megawatt hour. And the price is higher, so the aluminum plant will have to be shut off. Same story a bit with the gas-fired power plant. So the wind and the solar panels, of course, will deliver, but this old gas-fired power plant will not be operational. Now, what is important to know is that everybody pays the same price, and also everybody gets the same price. So the consumers don't have to pay a very high electricity price. They have to pay 50 euro per megawatt hour. And the wind and the solar panels, they get also 50 euro per megawatt hour. So everybody gets the same price. So this is how the day ahead market function. I hope it's clear to you. And let's move on. Here is a result of an auction at the day ahead market. Now, what's important to know is that we do this process for every hour of the day. So we do it for from 2 to 3 o'clock in the morning, but also from 7 to 8 in the evening. And you can see here the prices that came out and the electricity volumes that came out. Now, what's interesting to note, we see here a price peak, which is early in the morning, and we see a price peak around 6, 7 in the evening. This is not a coincidence because it's related to the fact that us consumers, we consume more electricity in the morning, in the evening than during the night. And also less so during the middle of the day because then we're typically at work, so we don't do a lot at home. So you can see this pattern back in the prices of this market. Now, if you want to know more prices, you can look them up on the internet, and here are some links that give you access to price information for different European markets. An interesting curve to look at is the yearly curve of the day ahead market. Now, what does it consist of? It basically consists of the prices of all the hours in the year. So all 8,760 hours in the year. But in that curve, you don't plot it from in time, so not from the 1st of January to the 31st of December. No, in the curve, you plot it from the highest price to the lowest price. That you can see here. So here we have the hours in the year, and here we see the prices. So on the left, you see that there were certain hours in the year that the prices were very high, up to almost 100 euro per megawatt hour. But there were also hours in the year that the prices were very low as 0 euro per megawatt hour. Now, what is interesting is that you can relate these prices to certain situations in the market. For example, the high prices can be related to a combination of a low electricity supply, for example, a very misty February day when there's no wind and sun, combined with possibly power plant trips, and combined with a very high demand for electricity, for example, in the morning or in the evening during a football match. Then you also have the situation of a very low prices that you can connect to excessive renewables generation of wind and solar, connected to a very small demand. Could be during the night, obviously, then there's not a lot of sun, but there can still be a lot of wind. Can also be the middle of the day on a very sunny summer day where everybody's on the beach, so nobody is using any electricity. So what is interesting to see in this curve is that it already shows this effect of renewables on the curve. And this is actually a graph for 2014. I think it's still quite comparable today. But in our present day system, we still don't have a lot of wind and sun. It's only a small percentage. And it already has a significant influence. This curve will drastically change in the future, and it will be significantly more volatile with much higher prices here on the to start with, and low a much longer time of relatively low prices. And this is really important for these future electrochemical processes, because it basically means that you're not going to operate these processes all the time. You only want to operate these future electrochemical processes when electricity is sufficiently cheap. Otherwise, it's just not attractive. There is one more market I want to briefly discuss, which is the balancing market. In that market, electricity is basically bought and sold real time. So electricity you use now, you pay now. And that market has much more extreme price fluctuations than the day-ahead market. And that you can see here. Here the blue line is the day-ahead prices I just showed. But now the red line are the balancing prices. And now what's interesting to see is you see hours of very high prices, as high as 400 euro per megawatt hour. But you also see hours with negative prices. So this is also possible. Sometimes there's an oversupply of electricity on the grid. And yeah, then it's basically people are paid to use that electricity, because if nobody uses that electricity, then the grid becomes unstable, and that's what the grid operator does not want. So you can get then significant prices to take off electricity. Doesn't happen that often, but still interesting to know, and it's also something you can take into account when designing your electrochemical process. There can be these hours that are attractive, so it helps your business case. That already brings us to the end of module 9. Here are the key takeaways. So electricity costs are normally the main variable cost in an electrochemical process. Variable costs, fixed and capital costs together determine whether an electrochemical process is economically attractive. Electricity is being traded on different markets, and electricity prices can vary strongly over time, which should be taken into consideration when designing an electrochemical process. Well, I recommend you here to carry out the last quiz question, 9.3. And with that, we come to the end of the final screencast. So you have made it until the end. Congratulations. I hope you have learned a lot from this screencast, because that was the goal. Yes, I hope to see that in the written examination and also in the assignment. But for now, I would like to thank you for your attention, and goodbye.